Hello, good day once again. I am Dr. Ramela B. Ramirez once again. I am going to discuss with you another problem in physics this time. This is all about relative velocity. So according to this problem, we have a boat that can travel 1.85 meters per second in still water. If the boat heads directly across a stream whose current is 1.2 meter per second, what is the velocity, including the magnitude and the direction of the boat relative to the shore? So again, we have a boat which can travel 1.85 meters per second in still water. If the boat heads directly across a stream whose current is 1.2 meters per second, what is the velocity, that is including the magnitude and direction of the boat relative to the shore? So again, the best way to solve for the problem such as this one is to translate the worded problem into figure or into illustrations. So in this particular case, what we are going to do is to draw the figure, and according to the problem, we have a boat which is moving in still water with a given velocity. So let me draw the figure. Okay. Let's say this is the velocity and still water. Sorry, in the of the boat relative to the shore is to be determined. And we have the boat heading directly across the stream whose current is 1.2 meter per second. So let's say this is the current, meaning that is the velocity of the water, which is 1.2 meters per second. And we have a boat which is heading directly through it across the stream. So that means the boat's direction can be represented using this arrow. Let us represent this to be the velocity of the boat, which is given 1.85 meters per second. So the question here is, what is the magnitude and direction and the velocity of the boat relative to the shore? So if this is the shoreline of the ocean or the water, and that the current is going into this direction, while the boat is going towards it, directly hitting across the stream, what we are going to do is to determine the relative velocity of the boat. So if you would notice here, we can create here a right triangle. Okay. Again, whenever we are solving for problems such as this, it would be best that you know how to translate the worded problems into figure or illustration. So if you have here the boat relative to the shore, this can be represented to be the direction of the boat relative to the shore. And that is what we are going to determine, that relative velocity of the boat. So if you have here the boat which is going into that direction, okay, if that is the boat heading towards that direction, we can represent V as the relative velocity of the boat. And we have here the angle. Let us represent that as the angle theta. So based on the figure, you have a right triangle. And if you are going to recall in your trigonometric functions or trigonometric formula, we can determine this value of the velocity by simply making use of the Pythagorean theorem. So according to Pythagorean theorem, c squared is equals to a squared plus b squared, if you are going to remember that equation. And if you would notice, we can represent the value for c to be the relative velocity, and the value for a and b can be represented by the velocity of the water or the current and the velocity of the boat. So if we are going to make use of the velocity of the water plus the velocity of the boat squared, both in the squared. So you have here from this formula of Pythagorean theorem, so we can now continue solving for the velocity. Okay, so let me continue with solving with the velocity. The velocity v squared is equals to 1.1.2 squared plus we have 1.85 squared. And there you go. We will be able to determine the value of the velocity. The square root of 1.2 squared plus 1.85 squared. So we have the velocity now, which is equals to, by calculation, we will have the value, which is 2.21. The unit is in meter per second. But let me proceed with trying with the determining the magnitude and the direction. So aside from the velocity, which is 2.21 meter per second, let us try to determine the direction of the magnitude and the direction of the velocity. So in determining the direction, we need to find out the value of the angle. So the angle can be determined using the basic trigonometric function. So from the basic trigonometric function, tangent of the angle is simply equals to opposite over adjacent. It's the NOVA, opposite over adjacent. And there you go. You will be able to determine the value of the angle. So the angle is simply equals to tangent to the -1 of 1.2 over 1.85, or the angle is simply equals to, by calculation, 32.96, let's say 33 degrees. And that would mean the velocity, our answer will be, this is the relative velocity. That will be our answer. And in terms of the direction, that is, let me check. The direction will be at 33 degrees, and going down stream. Okay, so that will be the answer to the problem. So again, another tip, tips for solving worded problems such as this one, you need to translate first the worded problem into figures, then from the figure, you look for the possible equations, mathematical equations which you can use, the possible applicable mathematical equations which you can use in solving for the different unknown variables. So that would be all for today. Again, this is Dr. Ram at your service. I shall see you in my next video tutorial.